Hello everybody, it's me again, Mr. Gravea. Today we're going to be looking at lesson 8.4, which is solving equations by inspection. So our learning goal for today, we're going to be writing equations, algebraic expressions, that have letters and numbers, and solve them by inspection. Basically what this means is that we're going to be working backwards. We're going to have the answer and then figure out how we got that answer. Instead of working towards the answer will already be given to us. So let's take a look. Here's our first scenario. We have this design here. We have some what are supposed to be toothpicks. Bear with me, but they kind of look like that. Here's the first figure. Here's the second figure. Here's the third figure. And first thing I've done is I've created a T-chart to help us figure out the number of toothpicks. So first, figure 1. So I have number of squares, number of toothpicks. So there's 1 square in figure 1, 4 toothpicks. There's 2 squares in figure 2. That's 1, 2, 3, 4, 5, 6, 7 toothpicks. Third figure, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 toothpicks. So 4, 7, 10, if I kept that going, it would be 13, which means there's a common difference of 3. It's going up by 3. All right. Now, what's the relationship going across the chart? How do I use the number of squares to help me figure out the number of toothpicks? Well, we know that the common difference always tells us what number we end up having to multiply by. So the add 3, add 3, add 3 becomes times 3, times 3, times 3, times 3. Then we just need to figure out what's missing. So 1 times 3 is 3, but I got to get to 4, which means I need to add 1. 2 times 3 is 6, but I got to get to 7. That means I need to add 1 more. 3 times 3 is 9, but I got to get to 10, so I got to add 1 more. 4 times 3 is 12, but I got to get to 13, so I got to add 1 more. So what does that mean? So our pattern rule is if you take the number of squares and you multiply it by 3 and add 1, you'll always get the number of toothpicks. Or if I want to write that as an algebraic expression, S, so S for squares, times 3 plus 1 gives me T, number of toothpicks. So if I had, for example, 5 squares, what would it be for the 5th square, the 5th figure? Well, my algebraic expression, S times 3 plus 1 equals T. S for squares, T for toothpicks. If I put in what I know, 5 times 3 plus 1 equals T. Then order of operations tells me I need to do the 5 times 3 first. So 5 times 3 is 15. Then I have 15 plus 1 equals T, and T equals 16. So after 5 squares, I'll have 16 toothpicks. What if I have 18 squares, or the 18th figure? Well, I have my algebraic expression. S times 3 plus 1 equals T. Now all I need to do is take out the S, put in an 18, so it looks like that. 18 times 3 plus 1 equals T. Order of operations tells me I need to do multiplication before I do addition. So 18 times 3 is 54. 54 plus 1 equals T. 54 plus 1 is 55, so 55 equals T. All right? It's this right here is what we've been doing so far anyway, so nothing too crazy there. So here's where the inspection comes in. What if I give you the T, but I don't give you the S? So what if you had 28 toothpicks? How many squares could you make? Or which figure would have 28 toothpicks? Well, I start with my algebraic expression. That doesn't change. S times 3 plus 1 equals T. But in this case, I don't know the S. I don't know the squares. But I do know the toothpicks. So I can take out my T and I can put in what I know. So in this case, I know that T equals 28. S is still the same because I haven't figured that part out yet. My 3 and my 1 don't change. Now comes the inspection. I need to get this S by itself, which means I need to start moving the times 3 and the plus 1. I need to move everything that's not a letter, not a variable, over to this side of the equal sign, over to the 28 side. So which one am I going to move first? Am I going to move the times 3 or am I going to move the plus 1? Well, in math, we have a rule. Anything that's right beside the variable We can't move just yet. That's the last thing we have to move, which means I have to move my plus 1. So my plus 1 gets moved to the other side of my equation. I move it to the 28 side. So now that's going to look like something like this. S times 3 equals 28 minus 1. Now you might be thinking, hold on, wasn't it plus 1? Why is it minus 20? Why is it a minus 1 now? Because whenever we move across the equal sign, if we move to the right of it or move to the left of it, you have to change the operation. So before we had plus 1. Once we move, it now becomes minus 1. So S times 3 equals 28 minus 1. I still don't know what S is. My 3 I'm not ready to use yet, but I can do 28 minus 1. That leaves me with S times 3 equals 27. Now I can move the operation, or I can move the number that's right beside the variable. In this case, it's the times 3. So I take my times 3 and I move it to the other side where the 27 is. And because I'm crossing the equal sign, I have to change operations. So what was once times 3 on the other side becomes divided by 3. So S equals 27 divided by 3. Now my S is by itself, which is what I wanted. 27 divided by 3 is 9. So that means if I had 28 toothpicks, I could make 9 squares. All right? Let's look at a couple more examples of inspection. Let's say I had n plus 6 equals 13. So a number plus 6 equals 13. According to the rules of inspection, I want to get this n by itself. I want to get this n as the only thing on the left side of the equal sign. I want the plus 6 over here where the 13 is. So I'm going to move my plus 6 over to where the 13 is. But because my plus 6 is crossing the equal sign, it changes operations. So it goes to the opposite. Instead of plus 6, it becomes minus 6. So my n is by itself. Now n equals 13 minus 6. Well, 13 minus 6 is grade 1 math because I know that n equals 7. Which means if I take this 7 and I put it up over here, I would just have 7 plus 6 is 13, which is, we know to be true. All right? Let's look at another one. 9p equals 63. Well, as I've discussed in other videos, whenever you see a number and a variable beside each other and there's no operation, there's no operation that you can see between them, what it really means is multiplication. You'll have to excuse my janky writing here. So 9p equals 63 is the same thing as 9 times p equals 63. Now I want to get this p by itself, which means I have to move everything else, the times 9, over here to the 63 side. And because it's crossing over the equal sign, it becomes divided by 9. Instead of multiplication, it becomes division. Easy enough. Now my p is by itself. We just took the 9 times, we move it over here, now it becomes division. P equals 63 divided by 9. So now it's just 63 divided by 9, which I know to be 7. So if I take this 7 and I put it over here where this p is, I have 9 times 7. 9 times 7, that's 63. Let's look at another one. 7r minus 1 equals 20. So in a perfect world, I want to get this r by itself. So I have to get rid of the 7. I have to move the 7 and I have to move the minus 1. Well, because the 7 is attached to the r, I can't move it just yet. So I need to move this minus 1 first. When I move the minus 1, it changes operations. So that gives me 7r equals 20 plus 1. Well, 20 plus 1 is an easy one to figure out. And notice, because I haven't done anything to my 7r, I just write it again. Now I have 7r equals 21. Well, I know that 7r is the same thing as 7 times r. So 7 times something will give me 21. I need to move the 7 times over to where the 21 is. And when I cross over the equal sign, I change operations. I do the opposite of multiplication, which is division. Now I have r equals 21 divided by 7. So 21 divided by 7, r equals 3. That means if I take this 3 and I put it in here, if I put it up here, I'll have 7 times 3, take away 1 is 20. Well, 7 times 3 is 21, take away 1 is 20. And that's how you can always check your answer. Is take whatever you got as your variable, put it into your original question, and if it works out to be your answer, then you're good to go. All right? That's what inspection is. You're double checking. Let's look at a word problem. All right? So we've got, let's see here. Omar wants to rent skates. The rate is $3 plus $2 each hour. He has $21. What is the greatest amount of time Omar can rent skates? So because it's a word problem, first thing I'm going to do is I'm going to circle all the numbers. So I know at some point I got to use a 3, and I got to use a 2, and I got to use a 21. All right? Next, I'm going to underline the math words. So there's the word rate. Okay, rate is a constant, goes up by that amount. There's the word plus, each, and if you watch my video on 8.3, you know that each just means times. You're going to be multiplying. We know our answer needs to be in time. And greatest. So we're looking for a bigger number. All right? So first thing I'm going to do is figure out my algebraic expression. So what is the sentence that's going to help me solve this word problem? So here's what I have here. AE. AE just means algebraic expression. So I know that $3 plus $2 times, I have H. H is for hour. Equals C. Equals the cost of the skates. All right? That's what I know. That to rent the skates, the cost, I got to do all this. I got to take $3 times it by $2. Sorry, $3 plus $2 times H. Now, what does this have to do with Omar? Well, let's take this algebraic expression and let's put in what we know. So in this case here, we don't know how we're trying to find out because the greatest amount of time we're trying to find out for H. We don't know what H is, but we do know the cost. We know the cost because I've used my 3 and I've used my 2, but now I can use my 21. Why am I using 21? Because this is the cost that Omar has. This is how much money he's going to spend. He just wants to know how much time he's getting. He's trying to get the H. So what we do is we rewrite the algebraic expression with what we know. 3 plus 2 times H, that doesn't change, equals, and instead of writing C, we write 21, because that's what we know. Now we need to get this H by itself. We're trying to figure out the cost. We're trying to figure out the amount of hours. So I need to start moving I need to move the 3, and I need to move the 3 plus, and I need to move the 2 times. But I can only move them one at a time, and I have to do the one that's not beside the variable first, which means I'm going to be moving the 3 plus. So my 3 plus, when I move it to the other side, turns into 3 minus. So 2 times H equals 21, take away 3, because it was plus 3 on this side. So now it's minus 3 on this side. Okay? And notice my 2H is exactly, I didn't change anything about how I wrote 2H because I didn't do anything to it. I didn't use the 2 and I didn't use the H. Well, now I can do 21, take away 3, which gives me 18. Now I have 2H times 18, but I need to get this H by itself. So now I need to move the 2 times. Well, when I move it to the other side of the equal sign, it switches operation. So it's no longer multiplication, but it is division. So H equals 18 divided by 2. 18 divided by 2 is 9, which means that Omar can rent skates for 9 hours. How can I double check to see if 9 is correct? I can take 9, go back up here, and I can take out the H and put in 9. So that means 3 plus 2 times 9 is 21. Let's do that mentally. So remember, I would have to do multiplication before I do addition. So 2 times 9 is 18, plus 3 is 21. So it works out. Let's look at another one. So I've got here this pattern. Figure 1 has 2 red squares and 4 green triangles. Figure 2 has 4 red squares and 4 green triangles, and figure 3 has 6 red squares and 4 green triangles. So in all of this, what's not changing? The number of green triangles. It's always 4. So that tells us that our constant is going to be 4. We're going to be adding 4 to something. So if I wanted to, now what if I wanted to figure out what figure number will have 28 blocks? How do I go about doing that? First thing I'm going to do is create a T-chart so I can record what I know. I know that figure 1 has 6 blocks, figure 2 has 8 blocks, and figure 3 has 10 blocks. All right. What's the common difference? Plus 2, plus 2. The plus 2 turns into the times 2. The common difference is what we use to multiply. So 1 times 2 is 2, but I need to get to 6. How much more do I need to add? Well, I need to add 4. That's for the green triangles. And notice we're going times 2, times 2, times 2. If I look at the red squares, 2, 4, 6. It's the multiples of 2, times 2, times 2, times 2. 2 times 2 is 4, but I got to get to 8. So what do I have to add? 4 more. 3 times 2 is 6, but I got to get to 10. What am I adding? 4 more. So what's my algebraic expression? Well, if I take my figure number and I multiply it by 2 and add 4, that'll give me the number of blocks. How can I write that using variables? F times 2 plus 4 equals B. F for figure number and B for blocks. Now, the question said, what if I have 28 blocks? What figure number would have 28 blocks? All right, let's use our algebraic expression to figure that out. So I have my algebraic expression. F times 2 plus 4 equals B. I don't know what F is. That's what I'm trying to find out. But I do know what B is. So I'm going to rewrite my algebraic expression, take out B, and fill in the 28. So F times 2 plus 4 equals 28. Now I need to find out what F equals. So first thing I'm going to do is I'm going to move the 2 and I'm going to move the 4 over to the side. But I can't do them at the same time. Which one am I going to move first? The times 2 or the plus 4? I'm going to move the plus 4 because it's not beside the variable. The one that's right beside the variable, that one has to wait its turn. So my plus 4 is going to move to the other side. It's going to go over here where the 28 is. And because it's crossing the equal sign, it switches operation. So it's no longer plus 4, it becomes minus 4. And on the left-hand side, I just write whatever I have left over. I still have my F times 2 equals 28 minus 4. So 28 minus 4 is 24. That leaves me with F times 2 equals 24. So something times 2 gives me 24. Now I can move the times 2 over to where the 24 is. I'm going to rewrite what I have left, which gives me F equals 24 divided by 2. Now I just do the simple division. F equals 12, which means that figure 12 will have 28 blocks. All right. This is what inspection is. Using what you know, which is sometimes the answer, using what you know about one variable to help you figure out the other variable. All right. So watch the video as many times as you need to. Please complete the homework. You might notice in the homework for question number 5 that there's a lot of slashes. Don't worry about that. I think that's just a typo on Edwin's part. That doesn't mean anything. For question number 5, just pretend the slashes aren't there. I think they're going to, I'm not sure why they're not there, but they're not needed. All right. If you have any questions, please put them in the comment section. Thank you.